Good morning, student. Welcome for today's science session in 7th. How are you all? I hope you all are well, good and fine. Okay, we are going to start a new chapter, that is time and motion, and it is chapter number 13, right? And what does it mean, time and motion? What does this relation means? Time we are talking about the regularity of your breakfast for going school, you're going to study, all this are managed with your time schedule only. So when you are managing the time, that is time measurement, time schedule, you are doing it. For most early days, wherever we are talking about our ancestors, how they manage the time, they don't have watch, they don't have calendars. How they manage their time schedule? We are having the watch, we know we have to start our class at 8 o'clock, we have to reach at the school timing at so and so, we have to take the breakfast at 9 o'clock in the morning or take the lunch in so and so time. But ancestors don't have watch. How they manage? How they come to know that this calendar or this festival is going to come on that day? So that's all we all going to study over here in today's topic. Let's start that. Okay. So measurement of time in ancient times I'm going to teach you. Okay. Solar day. What is a solar day? Solar day means a day. How they are recording this day, right? We are talking about this solar day. The time taken between one sunrise to the next sunrise. One sunrise to the next sunrise. This is one solar day. Second, we are talking about the time taken between one new moon to the next new moon. One new moon to the next new moon. That is a month. And then I'm talking about a year. What is a year? The time taken by the earth to complete one revolution of the sun. One revolution of sun is equal to 1 year. Okay. So in this way they are going to manage per day, means a day they are managing with the sunrise to sunset, that is 1 day has gone. And for the month they are talking about one moon to the next moon, what is coming out, that is how many moons they have gone. Then they can see the moon, that new moon is there, and half moon is there, and crescent moon is there. They come to calculate about this month, halfly month is gone, or how much days has gone of that month, right? Year they are talking about the revolution of the sun, that depends upon it, that now the sunrises take place early in the morning, or its sunrises take place late in the morning, like in winters almost sunrises near about 7 o'clock, like in January, and in May sun is rising at near 4:30 or 5 o'clock. So that's involved the one revolution of the sun, and it depends upon the year that summer has come, and all about the year they can calculate from that. Okay, so this about the measurement of the time by the ancestors. So our ancestors, for a short period, if they have to calculate that, we have to note it down. This work has done in so many seconds. We are talking about nowadays. कितने समय में हुआ है? So how they are going to calculate that? They are using the measuring devices, right? What are those devices? Sundial, sun clock, water clock. So what is sundial? You have seen in the Jantar Mantar. It is perfectly a sundial. Okay. And sun clock, it's like this shape. Sand is filled over here. When we tilt it, sand will go from here. They come to, they can calculate, like their work has to be done in so much of time, that when the sand enters from one triangle to second triangle, and they can calculate very easily in that seconds, the work has to be done. So sun clock is this way. Sun dial, I'll talk about that. Jantar Mantar also, that is prepared on this theme of sundial. And water clock is also, it's like one rotational clock is there, and one Vask is there, and when water is coming from this to here, this all depend upon this. how many cycle it is going to take place, and after how many time it is coming and adding over in the beaker, or whatever the bucket and all they're keeping over there. So this way they can measure with the water clock. They prepare with their own sun clock and sundial, of course. So that's all about the ancient time, how they calculate the time, how the devices they are using to calculate the mini seconds also. The work has to be done in so much of time. Nowadays, beta, clocks are used for measuring the time, right? Clocks we are using, and these clocks are depend upon which principle? Like it depends upon the periodic motion, right? It depends upon the periodic motion. And what is this periodic motion? A motion which repeats after regular interval of time. A motion which repeats after regular interval of time is called periodic motion. Okay, and this clock is depend upon this periodic motion. Okay, so a motion which repeats itself of a regular interval of time is called periodic motion. And clocks, where we are watching the time and on the schedule we are it's all depend upon, that is all depends upon this circulatory motion, periodic motion. Okay, so simple pendulum is a very good example. That can be many clocks you have seen that better. They are containing what? They're containing some pendulum. Big clocks, they contain pendulum. You have seen big clocks, old clocks, if you have seen that. So how they are working, I can show you. They're hanged from the wall or from the clock base, and after that they have attached with a long thread. Okay, they have attached with a long thread. You can mention over here, and attached to a bob. This is a metallic bob, beta. Metallic ball, I can say, and which is named as bob, B-O-B, bob. Okay, and now it is when we are stretching it and it is free to move. Like we are pulling it and we are making it free to move. And after this free to move, they go to their mean position to the extreme position. Like this is the bob and this is the mean position. And after releasing it as a free, it goes to the extreme position. A is there, we can write down A dash and B dash. Again, this is the extreme position and this is the extreme position. So this was discovered first by Galileo. Okay, is a scientist name. It's discovered first by this person, and this is a scientist. And you have understood the construction of this pendulum. You can see this very easily. You can remember this, learn it, you can draw this. Okay, and what are these length and what we will speak up, I'll take it one by one. Okay, now beta, let's talk about the parts or relation to this pendulum. What are the relations I'm going to discuss over here? First, the length of the pendulum. You can see in the diagram the length of the pendulum. This L I have mentioned. This length of this thread is L, and L is the length of the pendulum. Okay, from the mean hanging position to this bob where it is hanged through a thread, that is of how many length. Okay, so this is the length of the pendulum. Now the mean position of the bulb when it is at rest. Mean position is when the bob is at the rest. Okay, so when it is at the rest, it is called mean position, and the position A is called the mean position. We can denote it as A. Okay, so A is the mean position. A is mean position. You can write. Okay, extreme positions of the bob. When this bob is freely moving. Okay, when this bob is freely moving, then what will be the extreme position? When it is gone to this A dash and when it goes to B dash, then the mean position will be, this is extreme position, from mean to maximum position what it is getting, and from this side also the maximum position what it is getting, that is called extreme position of the bob. Okay, now oscillation of the pendulum, you can denote it as B and you can denote it as C. It will be more easier for you. Dash will make your confusion. Do it like this, A to B and B to C. It will be more easier for you. Okay, next is oscillation of the pendulum. What is the oscillation? Means to and fro motion. This motion is called to and fro motion. Back and fro to आगे से पीछे, and to and fro is this way. Okay, चलिए. Oscillation of the pendulum. We are talking about the oscillation of pendulum. One complete to and fro motion of the bob. One complete to and fro motion of the bob about its mean position is called oscillation. Its mean position से to and fro motion, what it is covering, it is called oscillation of the pendulum. So to and fro motion we are considering in this. Okay. Next, fifth point I am taking is amplitude of the pendulum. What is the amplitude? Maximum displacement of bob from this mean position to the extreme position. What is the maximum displacement? For the displacement is the shortest path, but here we are talking about the maximum displacement from A to B and B to C. That is called, and B to C, that's called back and forth motion, of course, and contains one oscillation. You can say A to B and B to C. Okay. Now, I'll talk about time period. What is the time period? One oscillation as the maximum displacement of the bob from its mean position. I'm talking about this again. The maximum displacement, what you will write in this. The maximum displacement of the bob from the mean position on either side of it. Either side of it is called this. And display, what about time period? How you will write that? Because you know one oscillation is equal to the time taken. So, how you will write? The time taken by the bob. Time taken by the bob of a pendulum to complete one oscillation. To complete one oscillation is called time period of the pendulum. Okay. Now, the time taken by the bob of the pendulum to travel from A to B and from B to C. Okay. So, finally back to A. Finally back to A. Means A to B, then B to C, and from back again to the mean position to A. That involves one complete oscillation that is equal to the time period taken by that one oscillation. I think I am clear. See, again I'll repeat it. What is one oscillation? When the bob start rotating in to and fro motion, it goes to A to B, and then B to C, and then back again to A. That involves one oscillation. And whatever the time is taken for this one oscillation is equal to the time period taken by the pendulum. Okay. Okay, next we are going to cover the frequency. Frequency of the pendulum. F is equal to, it's a formula, F is equal to 1 upon T. How you will do this? Beta, F is equal to 1 by T. How you are going to do this? Write down the T value over here. Okay. And what you will calculate the time from this and write down the value of T over here. So, F is equal to 1 by T. You can divide it and you will get the frequency of one oscillation of the pendulum. Okay. So, that's all are the elements that we have covered, or the relations I can say related to this simple pendulum, that you have to read it out, understand it, and one numerical also we are going to cover with this. Okay. Beta, let's start one numerical. A simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of this pendulum? So what it is given, I should write time taken for 20 oscillations. Time taken for 20 oscillation. How much time it is given, beta? It is given 32 seconds. Okay. Time taken for 20 oscillation is equal to 32 seconds. Now, time taken for one oscillation. Time taken for one oscillation. How we will calculate? If you are having 20 seconds, 20 oscillations time, then how you will calculate one oscillation? 32 by 20. 32 by 20. What will be the answer? Calculate it fast. Yes? It is 1.6 seconds. Okay. So, time taken by one oscillation is equal to 32 by 20. One oscillation we can take it out very easily. Calculated it and you will get it 1.6 second answer. Okay. So, what it is asked beta. Now, पूछा क्या है? What is the time period of this pendulum? What is the time period? Time period of the pendulum is, how you will write now? Time period of pendulum is 1.6 second. Okay, you have to write this. Don't leave it. You will not leave over here. You will write this. Okay, this makes a complete answer. So this is the numerical for the practice I have done. Practice more numericals for this from this concept and prepare well from this all the relation. Further we will take new topics in the next lecture. Till then, thank you. Have a nice day.